This video is about reverse mapping. To depict how reverse mapping is used to determine probabilities of phenotypes and genotypes of gametes based on the recombination of 3 genes, we will focus on the fictional species mermaids. We will be working with 3 loci: tail color, hair color, and fin shape, the dominant alleles being green tails, blue hair, and forked fins, and the recessive alleles being purple tails, red hair, and non-forked fins. Here is our parental test cross with a homozygous dominant female and homozygous recessive male. This is the F1 offspring that resulted from the parental test cross. It is heterozygous in terms of genotype, however this female mermaid inherited the dominant mother phenotypes. Here is our test cross between the F1 female and a homozygous recessive male. This could result in offspring who undergo recombination or no recombination. If a single crossover 1 event occurs between the G and B loci, it could result in purple-tailed, blue-haired, and fork-finned offspring, or green-tailed, red-haired, and non-fork-finned offspring. If a single crossover 2 event occurs between the B and F loci, it could result in green-tailed, blue-haired, and non-fork-finned offspring, or purple-tailed, red-haired, and fork-finned offspring. In the case of a double crossover occurring, it will result in a green-tailed, red-haired, and fork-finned offspring, or a purple-tailed, blue-haired, and non-fork-finned offspring. In order to calculate the probability of specific gametes resulting from a given event, we will use the R1 distance between the tail color and hair color loci, which is 12 centimorgans, and the R2 distance between the hair color and fin shape loci, which is 5 centimorgans. For the coefficient of coincidence, we will use 0.9. Here we have the 8 possible phenotypes that will result from the F2 test cross. The first 2 events are SCO-1 events that are single crossover events at region 1 on the genetic map, and the third and fourth events are SCO-2 events that are single crossover events occurring at the region 2 on the genetic map. The fifth and sixth events are DCO events, which are known as double crossover events, and they are least likely to occur because it will require the offspring to undergo not only 1 crossover but 2. The final 2 events on the chart are NCO events, which are non-crossover events that will resemble the parental phenotypes and genotypes. These are the most likely to occur because it is more likely for offspring to not undergo crossover than to undergo a crossover event. To elaborate on how I solved to find some of these probabilities, we will use the example DCO event and one of the SCO-1 events. Here you can see that to find the DCO probability of the event occurring by multiplying the centimorgan values from region 1 and region 2 together, along with multiplying it by the coefficient of coincidence value. To find the probability of a specific gamete resulting from a DCO event, you will simply multiply your first value by 1/2, because there is a 50% chance to get either DCO event outcome. Finally, you'll multiply your answer by 100 to turn the decimal into a percentage. To find the SCO-1 probability of the event occurring, you will subtract the probability of the DCO event occurring from the centimorgan value of region 1 on the genetic map. To find the probability of a specific gamete resulting from this event, you will simply multiply the probability of the event occurring by 1/2. This value should be multiplied by 100 to convert to a percentage.